Okay, in this video I'm just going to go through a couple of examples on the hyperbola. Now, first one, okay, we've got y equals 2 on x. So we've actually got a dilation of factor 2. Okay, so in green I've already drawn the y equals 1 on x. Now we're just going to have a look at what happens when we have 2 on x. Now these points here, remember, are 1, so this one's 1, 1, this one's minus 1, minus 1. So it's a good reference point to look at with dilations. What happens to that point? So before we had y equals 1 on x. Well, if we've got 2 on x, it's going to dilate the graph. And so we're either going to have a compression or a compression where it goes closer towards the origin, or a dilation which goes out. And at the moment we've got something that expands it. So at the point 1, 1, that will then become okay, so at 1, y becomes, it's actually 2 now. So we actually increase it. So that point there goes up. Now, what happens when we go, okay, at x equals 2, just giving some points. Okay, we get 2 on 2, which is 1. So this point, when we go across to 2, gets pushed up as well. And I can do a third point. Okay, moves up a little bit as well. So all these points, okay, just move up a little bit. So I can connect the dots. So it has the same shape, it's just been dilated a bit. And same thing on the negatives. Okay, I won't put the dots in, but it looks something like that. So it's just been pushed out a little bit. So that's a dilation. Now we'll have a look at this second one. Okay, y equals 1 on x plus 2. And when we have a translation, it's good to start with the asymptotes. Okay, we know there's an asymptote that goes across and one that goes vertically. So like our quadratics and our cubics and all that, where we have some kind of, here's our ordinary function, what happens outside of it, well, it actually just gets pushed up to. So it's a good reference point to look at your asymptote and say, well, that line there is just going to get pushed up to. Okay, everything else stays the same. We're not dilating it, we're not translating it left or right. It's just been moved up to. The vertical asymptote stays the same. So now we just draw in our graph in the same shape for our new asymptotes. Okay, so in black, we can say it looks like that. Now it's good to label it sometimes. So we started with 1, 1. So what happens at x equals 1? We'll get y equals 1 on 1 plus 2, so it equals 3. So this point in here we can say is 1, 3. And the point down here at minus 1 we'll have 1 over minus 1 plus 2, so it actually becomes y equals 1. So it's a bit hard to see. Let's go minus 1, positive 1 will be that point there. And if you notice, we also have a x-intercept now because we've pushed it up. So our x-intercept, as usual, what happens at y equals 0, or x at y equals 1 over x plus 2. So take 2 across, times y. Okay, we've got a fraction, flip them, so actually get a minus a half for x. Okay, so important points to put are that little point there, that 1, 1, and where does it go now? Our asymptotes, I probably should label it as y equals 2 now. That's my asymptote. And also our x-intercepts and any y-intercepts that we find. So that's a translation up and down. Now this one we'll have a look. So very similar again, except this time because it's within the x function. Okay, this one was outside, so we move it up and down. This one's inside if we put it in brackets. Okay, it's going to do a similar thing, but we're going to move it left or right. And again, it's going to be the opposite. So if we go -2, we're going to push it to the right. Okay, so my vertical axis, my vertical asymptote is going to get shifted to the right twice. Okay, that's because when x equals 2, we'll have 1 divided by 0. It doesn't exist. And we've got a horizontal asymptote as well. And again, the shape doesn't change. So once you got those asymptotes in, okay, the shape stays the same. And we just need to label those points. For this one, well, we moved it across 2. So we're going to have x equals 3, and the y hasn't changed. For this one, we've moved it across, so it's going to be +1 and -1. Okay, I've just gone 1 plus 2 gives me +1. And I could find the y-intercept as well, just sub in x equals 0, because we've got a y-intercept now. 0 take 2, so 1 over 2. Okay, so that's left and right. This one's up and down and dilations. Last one to look at is a reflection. So we've got -1 on x. Okay, it just means that we have a mirror in the horizontal axes, and everything on this side gets pushed up, everything on this side gets pushed down. Okay, it's a mirror image. So same shape. Again, I haven't dilated it, so this point here at 1, 1 actually now becomes +1, -1. And this point here at -1, -1 now becomes -1, +1. Okay, that's all it does. Just flips it around the x-axis. One last example where we combine all of them. Okay, when you get something like this, okay, it's good to go in steps. So as you saw in the last couple of examples, we look at our reference point, I guess, and that's by the asymptotes. So my asymptotes, okay, where are they? Well, it's been moved across twice to the left, to the right. Okay, so my vertical asymptote is at x equals 2, and my horizontal is going to be, well, it's been moved up 1, so it's y equals +1. Okay, so good thing is to draw those in. Okay, I've moved to the left twice, and I've been moved up once. So draw your asymptotes in. Now, have we got a dilation? No, there's no number there or next to x, so we haven't been dilated, but we have got a reflection. So we start with something that looks like that, but because we've reflected it, it's going to go in these quadrants here. So I'm just going to draw those in. And if you notice, we get some intercepts as well. So we want to label that one and that one. So x-intercept, y equals 0. We get 0 equals -1 over x take 2 plus 1. Okay, bring those across. And if we make that a fraction, and then we can flip both of them, we'll have x take 2 equals 1 over 1, doesn't matter. Okay, plus 2x, so x equals 3. Okay, so that's 3, 0, and for the y-intercept, let x equal 0, so minus 1 over minus 2, so it's positive a half plus 1, so it'd be 3 over 2. So there's the 2 points. And then just label your x and y asymptotes, so y equals positive 1, x equals positive 2. That's pretty much it. Okay, so that's hyperbolas. I'll leave that there for now. And in the next video, we'll have a look at truncus.